Hey all you cool cats and kittens, welcome back to our Geo with Trig lesson. Today we're going to be doing Unit 10, Day 9, which is volumes of cones. So the last lesson we did was lateral area and surface area of cones, which again measure the outside area of the cone. Today we're going to be focusing on the volume of the cone, which is the space on the inside of it. So you can see from our two learning targets, by the end of this lesson, we'd like for you to be able to derive the formula or come up with the formula for the volume of a cone, as well as use that formula that we end up deriving to answer questions and solve problems. So the first thing that we are going to do is we're going to start by watching a quick video for the warm-up. And then at the end of that video, I want you to take a guess as to how many Hershey's Kisses there are in the box. Okay, so we'll click on that link and we'll play the video. Okay, so there you can kind of get an idea for the width of the box as well as the height of the box. And then Mr. Martinez takes out a couple Hershey's Kisses in order to give you an idea as to how big one Hershey's Kiss is. Okay. Then he goes back to the box to show you how many there are at that top layer. So what I want you to do is take a moment and take your best educated guess. How many Hershey's Kisses do you think there are in that box? Whatever your number is, you're going to write your guess right here. Okay. Now, obviously, this is just going to be an educated guess. So what I want you to think about is, let's say you had to actually come up with the best possible answer you could without counting. What pieces of information would you want to know that would help you be successful in this? What pieces of information could I tell you that will give you a more informed decision or a more informed answer? And then whatever you can think of, I want you to put down in this area here. So maybe things that could help would be something like, what are the dimensions of the box? So what's the width of the box? What's the height of the box? What's the length of the box? Okay, those are things that might help. Probably the dimensions of the Hershey's Kiss itself, right? So maybe if we had those pieces of information, again, this isn't any or everything. If you had some other stuff too, that's good. But just kind of thinking about what pieces of information might be helpful. So let's start by deriving. What is the formula for the for the volume of a cone? We start with this little recall that the formula for the volume of a pyramid is 1/3 times B times H, where again, reminder, capital B is the area of the base and H is the height. So from the highest point of the pyramid straight down to the base, that's the height. Now, since a cone can be thought of as a pyramid with a circle for the base, we can replace capital B in our pyramid formula with the area of a circle formula. Since again, capital B is the area of the base, and in a cone, the base is a circle, we're going to replace capital B with the area of a circle, which if you remember was pi r squared. So we're just going to rewrite our volume formula. We start out with V equals, volume equals, the 1/3 is still going to stay the same. But instead of capital B for area of the base, we know that's going to be pi r squared since the base is a circle. And then H, well, a cone obviously has a height. So this is our formula. If I want to know the volume of a cone, it's 1/3 pi r squared H, where again, r is the radius and H is the height. So these are the only two pieces of information that we need to know in order to find the volume of any cone. If we know the radius and the height, we plug those in, we solve. So let's take a look at our first example here. We have a cone. We can see that the radius of that cone is 6 inches. We see the height of that cone is 7 inches. Remember, the height of the cone is going to be on the inside. It's going to go from the top vertex straight down, or in this case, since the cone is upside down, the bottom point straight up. So we found our radius to be 6. We found our height to be 7. Those are the only pieces of information that we need, so we can plug those in. Remember, volume is 1/3 pi times r squared times h. So let's start plugging in the pieces we know. The 1/3 doesn't change. The pi is going to stay as a pi. The r squared, r is 6, so that's going to be 6 squared. The height is 7. Done. Now, I'm going to plug that into the calculator. You see that we have the exact answer and the rounded answer. So remember, when we want to get the exact answer, we plug everything into the equation except for into the calculator except for the pi. So I'm going to do 1/3 times 6 squared times 7 on the calculator. And this is to get the exact answer. 1/3 times 6 squared times 7. We see that comes out to be 84. So I don't completely disregard the pi. I just wait until the end. My exact answer is going to be 84 pi, and our unit was inches. Therefore, it's inches cubed. Okay, remember, volume, our units are cubed. Now, in order to get the rounded answer, we just include the pi in our calculation. I'm going to do the 84 times pi, and that comes out to be 263.89. 263.89 inches cubed. Okay. Remember, if at any point this is going a little too fast or you just need a re-explanation, you can always pause the video, rewind a little bit, and watch again. Okay. When we look at our next example here, we can see we need two pieces of information. We need radius, we need height. The height is right here, 15. And be careful about your radius. Okay, it's telling us this whole segment is 15 centimeters. So we want to divide that by 2 to get 7.5. That's the radius. The radius is 7.5. So if I want to know the volume, again, volume is 1/3 pi r squared times h. And in this case, 1/3 times pi times 7.5 squared times 15 to get that exact answer. Again, we just disregard the pi as we put this into our calculator. 1/3 times 7.5 squared times 15, or 281.25. If we wanted to, we could write this as 1125 over 4, and that's probably the better option to do because we don't want to have decimals in our exact answers. So this is how I'm going to write it. I'm going to write it as 1125 over 4 pi centimeters cubed. You could also put the pi on top. You could write it as 1125 pi over 4, but this is going to be our most appropriate answer. It's technically not wrong to have 281.25, but the more appropriate answer would be to put it as a fraction. Again, the way you do that, if you look over on the right-hand side of that decimal answer, you see that circle with a fraction inside of it. If you just tap that button, it's going to convert to a fraction for you. Okay. Now, if I wanted to figure out what the rounded answer is, I could take that 281.25, multiply it by pi, 883.57. And that's centimeters cubed. Okay. So what I'm going to challenge you to do is take a look at this last problem, see if you can figure out what our final answer is going to be. I'm going to give you a little bit of a clue here. Okay. Radius and height. We see the radius is 5. We don't know what the height is. The 13 is listed on the outside of the shape. It's the slant height. So what can we do to figure out the height? Okay, I'm going to challenge you to pause the video at this time, see if you can finish up this problem. If you feel like you still need the support and structure in the walkthrough, that's fine. Just keep watching and we'll go through this together. But if you feel like you can try it on your own, go ahead and pause it, try it, hit play, and you'll see how it works out. Since 13 is the slant height, we want to do Pythagorean theorem in order to figure out our height. We see 13 is the hypotenuse, so this is going to be 5 squared plus b squared is 13 squared. We subtract 5 squared from both sides. B squared equals. Now this is just me doing enough of these over the course of my math teaching career. 13 squared is 169, 5 squared is 25. This comes out to be 144. And when we square root that, we end up getting that B is 12. Okay, that is our height. So now that we have our radius and we have our height, we can find our volume. Volume equals 1/3 pi r squared times h. So again, I'll do that calculation without the pi. 1/3 times 5. Good thing I caught that. Notice how if I didn't tap over to the side, it keeps the 5 squared over on the bottom of the fraction. We don't want that. So tap over, there we go, times 5 squared times 12, and we get 100. So my exact answer is 100 pi centimeters cubed. And lastly, to get that rounded answer, just a simple 100 times pi, 314.16. If we round, 314.16 centimeters cubed. Okay? So there are basically the various types of which you could see a problem like this. You're given the radius and the height. Very straightforward. Plug in the numbers you're given. You're given a diameter and a height. Very simply, cut the diameter in half to get your radius. Or you're given a radius and a slant height, and you do Pythagorean theorem to find the regular height. The only other possibility for this type of problem would be maybe you're given the slant height and the regular height, and then you would do Pythagorean theorem to find the radius. But overall, it's the same concept as this one here in example 3. Okay? So hopefully that makes sense as to how we've been doing this. Really nothing is new in terms of how we get our different measurements. It's just what formulas we're plugging them into. So what we want to do now is bring this full circle, go back to our warm-up, all right? We want to know how many Hershey's Kisses were in that box. So here are some pieces of information. The dimensions of the box. The length was 25.5 centimeters. The width was 18 centimeters. The height was 8.5 centimeters. So find the volume of the box. Well, if we recall, the volume of a rectangular prism, we could do length times width times height. Length times width times height. That's going to be 25.5 times 18 times 8.5. When we do that, 25.5 times 18 times 8.5, that comes out to be 3,901.5. 3,901.5 centimeters cubed. So that's how much space is inside the box when it's empty. Now we're going to start filling that empty box with Hershey's Kisses. So what we want to do now is figure out how big is one Hershey's Kiss in terms of its volume. How much space does it take up? So pieces of information we have that the radius is 1.1 centimeters. The height is 3 centimeters. Using the volume we just learned, find the volume of a single kiss. 1/3 times pi times the radius, 1.1 squared, times the height, 3. So we will do 1/3 times pi times 1.1 squared times 3. And we get about 3.80, so we'll just call it 3.8. 3.8 centimeters cubed. Okay? So that's how big one Hershey's Kiss is. So if the box is 3,901.5 centimeters cubed and one Hershey's Kiss is 3.8 centimeters cubed, what should be done with the numbers that we found in order to find out how many kisses the box can hold, and then do that math? So hopefully we are thinking that if each kiss is 3.8 centimeters cubed and the box can hold 3,901.5 centimeters cubed, we would do 3,901.5 divided by 3.8. And when we do that, 3,901.5 divided by 3.8, 1,026.7. Now, obviously, we are not going to have 0.7 Hershey's Kisses, right? So it's either got to be 1,026 or 1,027. However you want to round is up to you. So it's either 1,026 or 1,027. Now, were you correct? If not, what could be some of the reasons why you were off? So, how do we know if we were correct? Luckily, on that same site, as we go down, Act 3, if we click on that, we can watch and see how we did. So if you remember the note that his grandma wrote, Mr. Martinez's grandma wrote, it said to share with your wife. So you can see he's divvying up. Now, luckily, we're not going to be watching this all go one at a time. All right, it's going to start slowly, and then you can see it starts to speed up. So now they're each at 10, so that's 20. And this starts to speed up drastically. And now the box is empty. Mr. Martinez has 428. Mrs. Martinez has 427. So, in total, 428 plus 427 comes out to be 855 Hershey's Kisses. Well, the number we got was 1,026 or 1,027. So what I want you to do is now be a critical thinker, be a problem solver, be a realist with your thoughts. We were wrong, okay? Our guess was about 150 Hershey's Kisses more than the actual answer. So what could be some of the reasons as to why we were off, okay? So think about what that might be. Maybe jot a couple of those down. And if you really want to know why we're off by so much, shoot me an email or come to the Google Hangouts and I'll be more than happy to tell you why that is. Okay? Otherwise, that's all we've got for today. Thank you guys for watching. And as always, if you have any questions or concerns, feel free to reach out to myself or Mrs. Flowers if she is your GWT teacher. And we'll catch you next time. Until then, take care, everyone, and be well.